Here we are. Let's talk about the quiz. It didn't go as well as I thought it would go. So I did give a curve. I can't hand it back. Right now, the normal process and the quiz 2 and quiz 3, because you'll be taking those on Thursdays instead of Tuesdays, I will be handing it back the very next class. And we will be going over it in detail. So we will be going over it in detail on Tuesday, because the other class is taking it tonight, but theirs is a different one. It's just that if they saw yours, it would give them hints. But what I am doing is, I could have posted the grades yesterday, but I thought to myself, no one's gonna show up. And look, you're all here, like almost all of you are here. So I think my new theory is don't post the grades, but here's what I'm gonna do. I'm gonna take the attendance sheet and I'm going straight to my office after we get done, and I'm posting everyone's grade who attended today, right after class. So check, give me about 15, 20 minutes after class and you'll see your grade. Here's the deal. 2 people, I think, maybe 3, thought this was the easiest quiz they've ever taken and just whipped on it. I couldn't do anything, they aced it. I couldn't find a problem, I couldn't find anything wrong with it whatsoever. But then there was 3 people-ish, maybe 4, 3 for sure, that said, hey, I want to test the theory if I can flunk this class. Even though, it's kind of designed not to flunk. So there's 3 people who said, I'm going to challenge this. I'm just going to do so poorly that I'm going to see if there's any way I could not pass this class. So there's 3 people that put their mind to it. And so what I had to do is, yes, not the 3 people got 100, but everybody who was below 100 got this slight little curve and brought the grade up a little bit. And by the way, the grade is,
what's the average?
Like, let's say, it's not that great. I don't even know if I want to say it. But here's the deal, it was 3.25. You have to figure out how many you got right, and that's your grade before the quiz, okay? So if you got like a -3, that would be, what would that be? 10.25 divided by that, somebody have to get a calculator and tell me what that is, but that's how you figure your grade before the quiz, or before the curve, excuse me. Now, those 3 people who said, hey, I'm gonna try to not pass this class right away, so I don't have to worry about this class because I know I'm never gonna pass, I gave them this unbelievable big curve because I want them to have a second chance to try to make it through this class. Now that there's an SI, now that they realize what needs to be done to pass my quiz. I mean, you got to admit, you realize the worst enemy on the quiz is the time. Would you agree with that?
Yes.
Yes. I mean, open book, open note, open PowerPoints, open everything I post on Canvas. If you guys had 2 hours, I would imagine 90% of you would get an A. So now you realize I don't change the system for the rest of the semester. You know now what to expect for quiz 2. You know what to expect for quiz 3. Nothing changes. Your enemy for both quizzes and the final exam are the same time. That's your enemy. That's it. So the more prepared you are by how organized you are, how quickly you can find the help you need, because I think once you guys were able to find the help you needed, the problems were great. It just looks like some of you, especially towards the end, had to give up a little bit and make guesses because you didn't have enough time, because maybe you spent too much time on some of the previous problems looking for the help you needed. That's very common. But now you know what to expect. You didn't have to memorize anything. The only thing you had to be familiar with is what kind of a problem am I reading and where do I look to get the help. That was it. I hope you noticed that the problems were very similar to homework. Even the wording I tried to make similar to homework. I didn't copy the book type of wording. I copied the wording I used on your assignments. But there were still some of you who didn't recognize, especially the binomial problem. I was shocked that a lot of people didn't recognize the binomial problem. But that wasn't the worst problem on it. The worst problem on it was, I think it was a question about the mean.
Yeah,
it was a multiple choice.
What was that?
And I could tell people were struggling on that because there were so many marks trying to figure out which one could be the answer for that. And a lot of you had it down to 2 answers, one of them being the right one, and then you chose the wrong one. I don't remember exactly what the answers were, and I don't know if I want to say it because I know it's going to be on the quiz. That may be one problem that is the same on the quiz tonight, out of 8 of them. The rest of them are different. Especially the problems are different tonight than what you had, but yeah, that one was the biggest challenge. I think possibly 50%, a little more than 50% you got that one wrong, and that was 1 point. So when you only have 13.25 points, that burnt you a little. I mean, take 12.25, just getting that one wrong, 12.25 divided by 13.25. I mean, I think you're still barely above a 90. I'm not sure if that's even a 90, I'm not sure. Just that one question. There was a half a point question. I think it had to do with maybe continuous and discrete, and it seems like most of you felt that one out. I believe, wasn't it asking you, and I know this isn't on the one tonight, but wasn't it asking you that you're going to be gathering grade point averages?
Yes.
Yeah.
Okay, so I thought for sure all of you know your grade point. So I thought this is going to be a gimme question, but yet there's still several of you who didn't get it right, so I was really surprised. But think about your grade point. If I pointed at you right now, and I make one up even, don't even tell me your real grade point, make one up. What's your grade point? What's your grade point? Hit me with one.
4.5.
4.5. Notice it wasn't 4, it wasn't a 3, it wasn't a 5. It was 4.5, which is impossible, but I love it. It had a point something, so it had to have been continuous. There's no way it could be discrete. By just knowing your own grade point, you would realize, oh, it can't be discrete, it's gotta be continuous because it was point something, right? So I thought that was a gimme, that's why it was only a half a point. But some of you still said, oh no, I can screw that up too. What else I want to say about the quiz is, there was one problem on there. I'm going to go in detail over, but before I go over it, hang on, I want to show you what that problem is. Where is it here? Hang on, where is it? Is it this one? Yeah, this one right here. Number 2, I'm going to go over in detail. Okay, this is not on the night one, so I can go over it in detail. And we're going to talk about it in detail. But before we do that, let's look at this. Here's week 4, but I want you to notice, if you go to syllabus, I haven't updated yet. At the top will be week 4, and then it will go week 5, 6, 7, all the way to quiz 2. So this is about to change today. But this up here, oh, it's not there yet. Also today, I thought I already put it there. Right underneath the syllabus will be a link where you can download a spreadsheet that looks like this. And you can calculate your grade and make sure that the grade on Blackboard's correct, that I have the right percentages assigned to each assignment by using this spreadsheet right here. Now I want to show you, when I post this, I already moved. You have to move the weights from column H to column G when you're going to enter a grade in. So I know we're entering a grade in for week 1 homework, week 1 in class, week 2 homework, week 2 in class, week 3 in class. We didn't have homework for week 3, and quiz 1. So we just finished quiz 1. I'm moving the weight over. So this is you downloaded this spreadsheet, you're keeping it on your hard drive, you're gonna update it as the semester goes on. Especially after each quiz, you wanna know where you stand in the class right after the quiz. Because that's a big percent of your grade, and you can see then how the assignments are affecting your grade with the quiz. That's what you'll be able to see. So I wanna go a topical. You're gonna enter your grades in J. It will only count whatever weights you moved from H to G. So this grade that appears down here in, what is this, M42, will be your grade as of right now if this class ended, after you put in your quiz grade. So let's do a hypothetical. Let's pretend this person's killing it on the assignments. Let's go with 100 on homework 1, 98 on homework, or in class, I don't know how that happened. 98 on homework 2, 100 on week 2 in class. Week 3 in class, what did we get? A lot of us got like 97, so let's go with 97. Now, you fell apart on quiz 1 a little bit. Matter of fact, maybe you scored about the mean of the class. Whoops, really? That low? Are you kidding? Seriously? Yeah, that's the average, you guys.
Not that bad.
Well, you kidding me? That's the lowest average on quiz 1 I may have ever had. I was just talking to him saying his section had more A's than any section I may have taught in 34 years. And this is the lowest average on quiz 1 I may have had.
Is this after the curve?
That's the,
Is this after the curve?
That's after the curve. So I don't know what's going on. But I was shocked as I'm grading, because quiz 1 is usually the confidence builder quiz. Usually it's the one, matter of fact, last semester's average on quiz 1 was 84. You're 70, what did I say? 76.5, right around there. Maybe it's 76.8. Hang on, let me switch it. There you go. Does that make you feel better?
Well, we're in progress. That's just the process.
So now, here's the deal though. Yes, this person only scored a C plus, right? C plus on the quiz, but look how well they did on the assignment. So what do you got to realize quiz 1 was 10% of the grade, but the assignments, if you add up, what is that? 1.8 plus 1.07 plus 1.8 plus 1.07, 107, 1, 2, 3, 4, 5, so 6, 7, you got about 7% in assignments, 10% in that. So this person's grade, I'm going to guess, it's got to be over an 80 still. Don't you think they still have over an 80? Let's take a look. Hang on, Remy. Hang on. 85.6. Now you see the effect of the assignment, right? This person had a C, right on the border of CC plus after quiz 1, but because of the assignments, if this class ended today, they would get, what is, is that a B?
Yeah.
Is 86 still a B or is that B plus? I can't remember. 84, 85, 86, that's a B. Solid B, a solid B. Would you walk out of here with a B and be happy?
Yes.
Oh, stop. He goes, no. Well, I'm telling you, if you only scored a 75.8 on the first quiz, I would hope you would be fairly happy because you need to make that recovery. If you're one of those people who you look at your quiz and you divide by 13.325 and you go, oh my God, I only got a 38? If you're one of those people, you don't have a 38 after the quiz. You had a 38, or after the curve, you have a 38 before the curve. You have a second chance right now. Figure it out, what you gotta do to never do that again. That's crazy. Because the quizzes don't get easier, they get harder. Showing up's the key, by the way. That's the key. Because the information that was on the quiz, I spoon-fed you in the lectures. The information will be on the next 2 quizzes, I'm spoon-feeding you through the lectures. So you know exactly what you should be studying and exactly what to prepare for. All right, so you know the process now. You can figure out your grade. When I post the quiz grades, check my math, make sure the total at the far end, I don't know what it looks like for students, but me, your overall class grades on the far end right. Make sure that's the same thing you get on the spreadsheet. If it's not, let me know. That means I have the weight slightly off maybe. It rounds it on Canvas, so the grade could be off by a couple of decimals maybe on the right, but it should be darn almost exactly what it is on the spreadsheet. Did you ask me a question?
Yes, sir.
You
No, I
did?
didn't.
Did I answer it?
No, I
Oh,
didn't ask.
please ask.
For the next quiz, before we hand them out, can we like walk around the class and check our work?
What do you mean? Walk around the class and check our work on the what?
Like the class assignment?
Oh, the homework, I posted the answers though the day after we had that last lecture.
No, I'm saying for the quizzes.
Okay, wait a minute, say it again. Walk around with the quizzes and compare with each other?
Yeah.
Oh boy, I like that idea. It will never fly. But, man, that's creative, because you know what? We're getting out early today, and I need some time wasting questions like that, so thank you, I appreciate it. But no, are you crazy? Why would I put up walls on everybody's side if I'm gonna let you guys compare? I just let you do them together in groups. Yeah, I wish we had a group project in this class. Is anybody taking operations right now? Because you are taking it? Taking operations at the same time you're taking this is rough. Is there anyone else in this seat? He's the only one? I think though you get a group project in operations, is that true? You don't know yet? Yeah. Yeah, we need one in here maybe. That may be the other thing to get your grade up. Don't get me wrong, we won't have it this semester, but I'm saying in the future. I only have 3 more semesters. That's all I have. You are my last class, last semester, and then there's 3 more and I'm done. That'll be 35 years. I don't know what that means. There's a party line. Thanks. All right, so what are we going to talk about now? You have your grades right after class, so we're going to go and we're going to this spreadsheet right here, and we're going to learn a new. No, you know what we're going to? We're going to this quiz question. We're going to this quiz question right here. I want to talk about this question right here. This was all about. It was all the things we learned about the number line, and then the number line in week 3 took it to where we needed to be, where you calculate Z. So this question on the quiz, the second question, was you using the Z chart and calculating Z, and most of you seem to have gotten it. Not everybody, but most of you seem to have gotten it. This is also going to be on your second quiz, because this is where we're starting the end of week 4, which is the beginning of the information for quiz 2. So this is going to be on your second quiz, so I want to make sure you get this. The bad news is, on your next quiz, not on the homework, you have homework problems that are exactly like this. The only difference is you don't need to tell, oh no, you didn't have to do that on the quiz either. You don't have to tell me which Z chart you're using anymore. You don't have to say it's the positive or the negative. You don't have to do that. But on the homework this week, that's due on Tuesday, you have I think three problems exactly like this, where you gotta show me manually how you got Z, then go to the Z chart, get the number off there, and then decide if you're done or if you need to subtract it from 1, if it's a more than question. You have 3 of those, but it also says in the instructions, after you do it manually, now also give me the Excel equation to solve it and the result. Now let me give you a big hint. Don't just assume the result from the Excel equation is the same manually, because the Z-chart rounds. So the Z-chart answer you're gonna get is slightly different than the Excel one because Excel is exact, where the Z-chart rounds. So they have slight difference. So you need to do both of those for all 3 of those problems. The last 3 problems in your homework are calculating Z manually and using Excel. So we're gonna review how to do it manually. We're gonna do this problem right here from the homework. Let's read it. Assume some data has a mean of 67, a standard deviation of 4.3. Show your detailed work calculating Z and give the probability from the Z chart to find the answer to this question. What is the probability for a randomly selected sample? See, it's just one sample we're taking right now. It's a randomly selected sample, one sample, having a value of 70 or more. Here's the formula. The number being asked about minus the mean is in parentheses as our numerator, divided by the standard deviation over the square root of sample size. Now, before today, it always was divided by the standard deviation. And I just slightly, right before the quiz, introduced you to the real equation, which is dividing the standard deviation by the square root of the sample size. Right now, every day, every one of our problems, the sample size has been a 1. So the square root of 1 is 1. The standard deviation divided by 1 is the standard deviation, so we just left that off. But we're heading to where there's no reason to leave that off. We're heading there, we're almost there. So that's why I keep bringing it up. Well, right now it's still a 1. There's how we do it manually. Tell me what the number is being asked about in this test question. Not all at once though, because it was so loud that I couldn't even hear you. 70, thank you. Minus, what's the mean? 67. Parentheses, because we got to do that subtraction before we divide. The sample size is 1, so I'm not going to do the whole formula, just the standard deviation in the denominator, which is what? 4 point what? 3 or 2? 3? Okay. 70 minus 67 is 3, divided by 4.3 equals, I don't know my calculator. I want 2 calculators, at least 2. I want a backup, which she's about to tell me. 0.6976. Somebody confirm? 77, is that true? No, matter. There we go. But we're using the Z chart, so what does that mean I have to do now? You can only use 2 decimals to the right to use the Z chart. So I gotta look at this, 0.697, wait, that's a 7, I gotta round up, but that's a 9. So that goes up to the next number, and so that goes to the next number. So this turns into 0.70. I can't tell you how many people thought that was 0.69 on the Z chart instead of 0.70. So if you use 69 instead of 70, which is about a third of you, believe it or not, you lost, is it a half a point? I think you lost either a quarter or a half a point, I don't know which, somewhere in there. What? Wait, you guys, what? It's 69, it's not 69, it's 70. Many of you went to the Z chart and used 0.69 and looked instead of 0.70. Does anybody remember that? No? Does anybody know that that's what they did? A whole bunch of you did it. All right, so now I'm going to the Z chart and looking at 7.0. The first number to the left of the decimal is a 0.7. The column we're going to use, that very first column, because that's the 0 column, so I'm looking at 0.7 on the positive Z chart. Going to the positive, there it is. There is 0.7, and the next digit says a 0, so to the left of my cursor there, 0.7580. And many of you instead gave me, let me go all the way here to 0.69, 0.7549, which is incorrect. That means you rounded and used the wrong Z. Now, let's go back to that question. I can't remember if I'm done or not. Am I done? I'm not done? Because what does it say? 70 or more. What's the problem? If that said what's the probability of 70 or less, I got my answer. A little over 75%, almost 76%. But it says 70 or more. So I have to now take 1 minus 0.7580, the opposite of that, which I know is going to be 76, which would be 2, 6, what is that, 20? 242?
Yes.
Darn it. 242. Oh, that looks familiar, actually. Now I realize. That is the real answer. That is the real answer. It's 0. I'll put a 0 because we're supposed to go 4 digits. There we go. 0.2420. If you didn't put the 0, I didn't take any points off, even though we're supposed to go 4 digits. Can everybody do this manually for the homework? Because let me show you the homework. Here's week 4 instructions. We had a quiz on Tuesday, then we have Thursday. One sheet of an instruction, but it's both the written and Excel on one assignment. So you're still getting, we just don't have the number line anymore. We're not doing number lines anymore. Written in Excel every week though. So here's written and Excel on one sheet. What else? This is due Tuesday, next week, yeah. There's our da-da-da, blah, 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 the normal stuff. And now, let's open the assignment, here it is. Here's week 4 assignment. There's one, forget those top 2 problems right now. Forget the third one. We're looking at the bottom 3, here they are. This problem right here says, if the mean is 12 ounces, standard deviation is 2.6 ounces, show detailed work to calculate the probability for 10.5 ounces or less. There you go, that's just like the quiz problem, exactly, isn't it? Using the Z-chart. But then, so you put that in the top half of your answer. Right below it, it says, then give the Excel NORMDIST, N-O-R-M-D-I-S-T function equation, the Excel equation, and result. So you gotta put that equation into Excel, even though you're writing down on your homework the equation and the result. You would enter into a cell on a spreadsheet to solve the same question. This next one, now use the same mean above, 12. The mean is 12. Standard deviation, 2.6, just like above. But show your detailed work to calculate the probability for 14 ounces or more. And instead of 10.5 ounces or less, this one's for 14 ounces or more using the Z-chart. Then, give the Excel NORMDIST function equation and the result. You would enter into a cell and spreadsheet to solve that same problem. There's 2 of them. The third one, if the mean is 254 and the standard deviation is 11, give the Excel NORMDIST function and equation and the result to calculate the probability for 266 or less. Write the equation just like you would enter into a spreadsheet for this problem. What is different about that last one compared to the top 2? Only Excel. That third one's only Excel. You don't have to solve it manually. Let me make sure you realize what I'm saying. This problem number 3 and problem number 4, I'm sorry, it's problem number 4 and problem number 5, both have to be done manually and do Excel. But the problem number 6, this very last one, is only Excel.
Can you put this question in Excel format? On the board?
I'm good. An Excel format, you said, right?
Yeah.
Yeah, I'm gonna put this on, we're gonna do Excel right now. Here we go. So here is the spreadsheet that's posted that helps you understand how to do NORMDIST. Now this spreadsheet has 3 different ones. NORMDIST has an S in the middle. We're going to talk about that in a minute. But that NORMDIST, we start using that next week. After you hand in your homework, that NORMDIST that we start using next week, which you're going to get introduced at the end of class today, is replacing the Z-chart. Starting next week, not this homework due next week, the next homework assignment, week 5, no more Z-chart for the rest of the semester. We have to use NORMDIST to replace the Z-chart from that point on. But on the homework, you're using the Z-chart. All right, so I just want to make sure you realize that's coming next week. NORMDIST, which is right here, is what you have to use on the homework that's due Tuesday. And the bottom one, NORMIMV, hang on, let me scroll down. I'm going to also lecture on at the end of today, but this is not on the homework. It might be on next week's homework, but it's not on this week's. So let me go back to the one that's on the homework. DIST, let me make it bigger. Here is the key information you need to know how to use this. Are you ready? Equals NORMDIST. You can put a dot in the middle there between the M and D if you want. Same equation. Does the same exact thing. NORM.DIST, NORMDIST, same thing. There's 4 numbers. The first number is the same number you would use in the top left-hand side of the numerator if you're doing it manually, the number you're being asked the probability of. That's the first number in the parentheses, the number you're being asked the probability of, which is the same number as in the top left of the numerator. The second number in the parentheses is the mean, which is the same number if you were doing it manually in the top right in the numerator. That's the second number in parentheses, the mean. The third number is the standard deviation. The same thing we're putting here in the denominator. Now, I want it right now for this homework assignment, that third number in the parentheses is just the standard deviation because our sample size is 1. But next week, is it next week or the week after, we're heading to where we'll have bigger sample sizes. You will need to have the whole equation there for the third number, not just the standard deviation. You'd have to have standard deviation divided by the square root of the number in the sample will be that number. But for this homework assignment that you're handing in Tuesday, just the standard deviation is the third number. The last number could either be a 1 or a 0, meaning is this about something or more, something or less, then it's a 1. If this is asking about an exact number, then it's a 0. But here is a giant hint. Hint number 1 is, if the problem's mentioning a standard deviation, you know it's a normal distribution problem. So now that you know it's a normal distribution problem, all normal distribution problems have a 1 on the end. You'll never be asked for an exact number. You'll always be asked for a number or less or a number or more for normal distribution probability problems. Because it uses continuous data, so always have a 1 on the end. There's a big hint. I want to make sure everybody heard that, so I'm going to say it again. You're going to have problems on the quiz, like the binomial one and this normal probability one that you calculated z. And you're going to have normal probability again on the second quiz. And it will probably be asking you to solve it using the Excel equation. Hang on, where was I going with this? I guess where I was going with this is that how do you know that problem? Because you're going to have these Poisson problems, you're going to have all these uniform problems, you're going to have these different ones now, and you got to be able to recognize them. You're going to go, oh, this mentions the standard deviation. I now know this is normal probability. Now that you know it's normal probability, you know that's the Excel function you're going to use. Now it's a matter of what's the number you're asking about, what's the mean, and we're heading to where right now you're just putting the standard deviation, but it's going to be the standard deviation over the square root of the number in the sample on the next quiz. That's what you need to get ready to be familiar with. But for the homework, it's just standard deviation. And then you know you're guaranteed to get the last number right, because once you realize it had a standard deviation, you're going, oh, this is normal distribution probability, you put a 1 on the end. That's all you're going to ever have to put on the end for this type of problem is a 1. We're always going to use a 1. It will be something or less or something or more. Now here's another thing that's weird compared to last week. Remember binomial? There was equals binomial distribution, parentheses, blah, blah, blah. There was equals 1 minus binomial distribution, parentheses, blah, blah, blah. Right? Does that look familiar? Okay. Do you remember when we were doing a more than, that we have to put a 1 minus in front, but that we have to put the opposite of the more than for the first number, which usually is like maybe a number 1 less than what's being asked about? Do you remember that? Okay. Now, for normal distribution, you never have to do that. You never, because we're using continuous data, that first number is always what's being asked about. Whether it's this number or more, this number or less, it doesn't matter. You put that number being asked about as the first number when using normal distribution. It's binomial that you got to worry about that first number. And did you notice on the quiz I asked the binomial problem, which was a more than, and you had to make sure you realized that this number is not the number being asked about? Did you realize that? Most of you got that one right, so I think. But yeah, some of you did kind of fall apart on that, I forgot. But yes. Yeah, there's a lot. There were some problems on this quiz. I don't know what that means. I gotta do a better job. That's all I can say. So where are we? I'm gonna try another one now. Are you ready? So, I'm gonna go back to this again. You ready? Give me the Excel equation. Here we go. The mean of this data is 67, standard deviation is 4.3. What's the probability, or give me the Excel equation right now for 70 or more. We haven't done that one. Give me the Excel equation for 70 more.
70.
Well, 70 is the first number?
Yeah.
It is, but am I norm distribution or 1 minus norm distribution?
1 minus.
1 minus because it's a more than. And it's 70. It doesn't have to be 70 or more. You don't have to use 69 or less, because this is a normal probability question. You can use that number. If that said more or less, you use the number being asked about as the first number. That's all there is to it. Comma, what's the mean?
67.
67. Comma, what's standard deviation? 4.3. Comma, what do we put on the end? 1. It's a no-brainer.
How do you know this question is asking for normal distribution?
Because it's mentioned as standard deviation. That's how you're gonna recognize it.
But didn't we have this question like on the quiz?
Yeah, that is from the quiz.
Well, we didn't use that.
No, you didn't use the Excel, but you solved it manually. We're learning how to use Excel now today. That's gonna be on the second quiz. Do you get it? This could be the exact same problem on the quiz, but it's gonna ask you to solve it with Excel. So you need to, I need you to realize, whatever number's being asked about is still the first number, even if it's a more than or a less than. Find the mean, standard deviation, and you know there's a 1 on the end, and you know it's a normal probability question because it's got the standard deviation in it. Go ahead.
You only use the first one if it's asking for exact or less?
It will never say exact on a normal distribution probability question. It will always say a number or more or a number or less. It may use the words differently, like at most and those type of words, but it will never say exactly. What's the probability of you picking one and it's exactly 70? It will never be on a normal probability.
If it's less, we're gonna use the 1 minus.
You wouldn't use the 1 minus, but it's the exact same numbers in the parentheses. No change in the numbers in the parentheses.
When we're not asking for standard deviation, what do you put in the third column? In like the third number?
The third number, what do you mean if you're not given the standard deviation, you don't have a normal probability problem. You're not using that function. You only use that function with the standard deviation.
But didn't you mention that then where if they're asking for standard deviation, you always put 1? And if they're not asking you
That's for bias, it's different.
No, hang on. No, this last number, you always put a 1 if you notice there's a standard deviation because you're recognizing that this is the function you're using, and you always use a 1 with this. What I was saying is, if they don't give you a standard deviation, it's not a normal distribution problem. You don't know what that last number is going to be because it's not this type of problem. Seeing that there's a standard deviation helps you realize, oh, this is this type of problem, so I'm definitely using normal distribution, but I know there's a 1 on the end. You know it because it's that type of problem.
How did we know to use the equation with the 1 minus the normal distribution?
She's asking, how do we know when to use the 1 minus, or any of them that happen to say, or more? Or it could say, what's another word for more? At least? It would at least be or more? At least, well, if this said at least 70,
No,
that'd be 70 or more, wouldn't it?
no.
Wait, yeah. Let me say it again. What is the probability of a randomly selected sample having a value of at least 70? That'd be 70 or more. It's the same way as saying 70 or more, at least 70. So anytime, if you look at a number line and the words are describing a number to the right, you know to use the 1 minus.
So if it's less, then you use the regular one.
The regular one without the 1 minus. That's the only difference between these two. The numbers in between the parentheses do not change, whether it's a more than or a less than, only that 1 minus in the front. Let's look at another one. I don't have another one. Yeah, right here, ready? Same mean, 67, standard deviation 4.3. Give me the Excel equation to find the probability that a randomly selected sample will have a value of at least 52. Tell me what should I change? Do I leave the 1 on the end?
Yes.
Standard deviation 4.3?
Yes.
67 the mean?
Yes.
What's the number to start with? 52? Is that what I said? 52? And then did I say or less or more?
At least.
More.
At least, so do I leave the 1 minus?
Yes.
You got it, that's correct. The mean is 67, the standard deviation is 4.3. What's the probability that the next sample item from the sample has a value of 68 or less? Okay, what do I gotta change? Is the 1 stay?
Yes.
Standard deviation 4.3?
Yes.
Is the mean 67?
Yes.
What's the first number? 68 and 1 minus?
No.
So equal, normal distribution, 68, 67, 4.3, 1. Exactly. These are that easy. You got it. Okay, good. Where are we? We did this. We did this. We gotta go to uniform. Oh, don't let me lose you. This is too easy. No, this is too easy. Oh, wait, what am I doing? Oh, wait, we're not done, I forgot, we got this perfect example we were using in business, I almost lost my mind. You ready? Wait, we're not done. Here's another example I almost forgot about. Now, I wanna tell you why this is such a great example. I used to work for this consulting firm, and my job was to travel around the United States to different businesses and spend usually it's like 4 days maybe with them. Sometimes I'd get it down to 3, maybe it'd take 5. But I'd fly out Sunday night, I'd spend a day with the business, and then I'd fly back, Friday night or Saturday morning or something like that. And what I was doing while I was there is I was an analyst for the consulting firm. And when I arrive, I start telling them all the things I need. I need to see, first of all, I start with their financial statements. So I have their financial statements for the last 4 years. And I'm working out ratios on their expenses compared to revenue, all the ratios. And I'm looking for anything that looks unusual. Like, why would this expense jump up so high this year compared to the previous 3 years? For some reason, something happened. And that's what I'm looking for as an analyst. I'm looking for different ratios. Then I'll go out and look at the inventory, and then I'll start asking questions to figure out what their inventory system is. How do they determine when to reorder inventory, or how's the inventory process once the truck arrives with new inventory? What's the process? How does the inventory then get out to the sales floor if it's a retailer, for example? These are the kind of questions I ask, and then I would always put together questionnaires that I would have all the employees to fill out, because it would ask them questions to get some insight from the employees as to why this company may not be making profit. Usually when they call me in, the company's not making profit. So my job was to analyze the company to pinpoint why they're not making profit, and then to make recommendations how they could make profit. And then either they do it themselves and I fly out, or they have a team come in from the consulting firm to make those changes I'm recommending for them at a very expensive cost. And then they're profitable after that point, after these changes make place. My consulting firm was so good at what they did, they would guarantee the company that if you don't make the profit we're telling you you're gonna make, which is more than paying us to make these changes, in the first year after we make the changes, we'll give you your money back. That's how confident this consulting firm was that I worked for, that they're gonna make sure you get a return on the investment if you implement these changes. So my job was to make sure truly this company could be turned around and truly could make money. So I learned a lot about companies, but what's great about it is that what a lot of companies don't realize is how much money they waste in inventory. I want to tell you, if anybody starts liking numbers and says, I would like to start an intern job or an entry-level job that has a lot of looks good upon, is quality control in a manufacturing environment is a good entry-level job to get your foot in the door, and inventory control, managing the inventory. The bigger the inventory, the bigger the job also. A big part of managing inventory that a lot of companies blow it is what's called the reorder points. Now let me make sure you understand reorder points. Now, I don't know if anybody's been watching the news, but the UAW auto workers are on strike, right? You guys realize this? And do you realize what the auto industry is having to do because of the strike that's taking place? They're laying off workers left and right. They have no choice, because the auto supply company, the auto manufacturing, led the way on what's called just-in-time inventory. This inventory process, the whole concept is that we order parts coming in, and we try to not have a whole bunch of parts in inventory, so we try to keep the order small, and we make sure, and while we're using the parts, that we place the order at the last minute, so that when the next truckload of parts arrive, we're just running out of parts, so there's no real big slack. They never want to run out of parts, because that could close down the whole line. But they want to be so low on parts that the truck arriving is like saving the day. That's called just-in-time inventory. It allows companies to free up millions of dollars from being held up by having too much inventory because they're overcautious. The bad news is, if it's a company that has a union that can go on strike, all the ripple effect from the strike is because the key places they went ahead and struck at these particular plants provide parts for a lot of the other plants. And because they have just-in-time inventory system, only took 3 days for them to stop making parts for all these other plants to run out of parts. And now they have to lay off all their employees. Thousands of employees are being laid off right now as we speak because of this strike, because of the just-in-time inventory system. But if a union didn't exist and a strike wasn't taking place, The just-in-time inventory system saves companies millions. It's a really good deal. And it's all based on the reorder point. So he's the only one in operations right now, and no one else I don't think is taking it. But this is a big deal in operations, is understanding that reorder point. And as somebody that takes an entry-level job at a company as the inventory manager, you talk about that you understand exactly how to calculate reorder points and how important reorder points are in an interview, that job's yours. Because they want to hire somebody who's going to be able to run the inventory and keep it thin enough to where they don't run out of things, but they don't have money held up in too much inventory. That's the key. That person that's paid, that's doing their job right. That's how they manage inventory. So, here's the deal. Reorder points are based on lead time. So as an analyst, I would go in and start asking questions to the people involved who were ordering inventory. Tell me your process now. Would be like with the inventory, the warehouse manager. Okay, you're about to run out of this one right here. It looks like you're down to 3. Tell me the process on, reordering this. And he or she may say, okay, there's a tag here. Like back in the old days, we didn't, Windows didn't exist yet. This is a long time ago. I'm an old man. I can't remember that. This is a long time ago. So there would be tags up, and he said, see the date there? This is the last time we ordered. See the date there. So I said, show me the process. And you go, okay, this one put there. I'm going to put an order. I go over here. He opens up a drawer, pulls out a form, puts the order together, sends it to accounting. And accounting then places the real order and gives what's called a purchase order number. A purchase order number is very important. In business, the supplier has to have that PO number because that's as good as money. They don't get the PO number unless that's a true order that they're willing to pay for, that the person buying is willing to pay for. That PO number is a big deal. I don't know if you guys ever watch Shark Tank? And someone will go, oh, I'm talking to Walmart and I'm talking to Target. And the sharks will always go, did you get a PO? That stands for a purchase order. Because if you don't have a PO, you really don't have an order. You're just talking. And companies will talk and talk and talk to try to get your price down, but they may never still order from you. That's how Walmart is. So purchase order. So then they say, oh, I got the PO, I put it in, and I give the PO so they ship the order. And then I say, now show me the date you ordered, show me the date it arrived. The date from when you ordered to the date it arrived from the supplier you're getting it from is called the lead time. You've got to know this. Lead time, let me repeat it. From the date they place the order to the date the truck arrives at the dock with whatever it is you ordered, that's called lead time. And companies, starting back in the 70s and 80s and 90s, they realized how important lead time is, so suppliers started saying, we're going to quicken our lead time. Because other companies say, even though you're charging 20 cents an item more, I'll order from you because you can get it to me a week faster than the other one. That's a big deal. That's that much less they have to hold up in inventory. Because from the supplier that takes 2 weeks, they got to buy so much more of it because it takes so much longer to get there. So lead time is a big deal. Reorder points are based on lead time. Are you ready? However long the lead time is determines the reorder point. Now, I wrote this example out. This business is open 7 days a week, so every day. From the time they place an order from the supplier we're talking about, it takes 7 days to get the order there. All right, you with me? 7 days from the placing it to arrive. That's the lead time right there. We have 25 in stock right now. Every time we place an order, we have to order 25. That's the minimum they allow us to order. So we have to at least buy 25. And we're selling on average 2 per day. Think about it. Imagine this. 2 are heading out the door per day. We're open 7 days a week. We're open 7 days a week. 7 days our lead time. Uh-oh, look at this. Two more just got sold. We're down to how many? 23. Oh, look at it. It's another day. 2 more just got sold. We're down to 21. On the computer it says 21. I went and checked inventory. Oh, we got 3 out here. We got 18 back in the warehouse. We're still at 21, right? My question for you is, what's the reorder point set at? Not 21, not 20. What is it set at that we have to place an order in order for that order to get here in time to where we'll be selling that last one as it's arriving based on the average amount we sell per day? What's the reorder point? How many do we sell per day?
14.
Said it, I heard it.
14.
There it is. Nice. When our inventory gets to 14, that's the reorder point. Because it takes 7 days to get here, we sell an average of 2 per day, 14 is how many we most likely will go through waiting for the order to arrive. 7 days for the order to arrive. We're selling about 2 per day, so we will most likely go through 14. So 14, where's my reorder point? My reorder point is going to be at 14. Now, here's the bad news. Life is never right there where you're selling 2 per day. But you aren't going to believe this. Most reorder points follow a normal distribution probability. And yes, 14's right here, but we could accidentally, I don't know, I'm making up a standard deviation, just hang in there with me. We could accidentally sell 15 or 16 or 17 or 18 or even 20. Or we may not sell 14, we may only sell 13, we may only sell 12, 11. These should be, based on standard deviation. I'm just throwing numbers up here for now. 10, whatever. Let's go with the 8 down here. All right? It could be any of those numbers. But how companies decide where to set that reorder point is based on the lead time and what the average amount per sell. And one more thing, what percent risk they're willing to take to possibly run out. Let me say that again. This is how companies decide reorder points. It's based on the lead time, it's based on the average amount we sell, and it's also based on how much risk we're willing to take to run out. Because some companies say, I'm willing to take risk to run out because my competitor is so far away, I know this customer will come back if I ran out, and I know the delivery is going to be coming the next day, and we just happen to sell a little more than our average, right? But then there's these companies who go, hey, I'm an auto supplier, auto parts supplier, retailer, and there's an auto zone only like a half a mile down the road. If I don't have it in stock, I know they're going to go to my competitor and buy it. So that person, that manager is saying, I don't want to take as much risk of running out as the other person. So what happens is, as a manager, you got to realize this, and you use statistics to figure out what the probability is of running out, and then you adjust that reorder point based on the amount of risk you're willing to take. Now let me show you how to determine if you're going to run out. Let's look at this example. Now this example is not using, this is a different example, so these numbers are going to be different here. Hang on. Let me cross them out until I read this story. Here's how to calculate the percent chance of running out. PepZone, auto parts supplier, has multi-grade oil. When the stock of the oil drops to 20 gallons, there's the reorder point, 20 gallons. There it is, 20's right there. 20 gallons and replenish orders placed. There's the reorder point. So here's what they're thinking. Whatever time it is they reorder, they have 20 gallons in place, right? But let's say all of a sudden, more sells than what they expected in the time we're waiting for the order to arrive. They're most likely going to run out. And the manager wants to know, what's the probability we're going to run out with a 20 point. So now what's the manager need? What's the mean we're selling over the time? And what's the standard deviation? So here we go. Store manager is concerned about sales being lost due to running out, stock outs, while waiting for an order. It's been determined that the demand during a replenishment time period has a mean, has a mean of 15, meaning however long it takes from the time we place an order to get it, called the lead time, we usually sell 15. But they set the reorder point way up here at 20, with a mean of 15 and a standard deviation of 6. So 15 plus 6, right here is 21. Hang on. So one standard deviation is 21 plus 6 more makes 27, and 2 standard deviations. 20 is going to be right there. There's 20. Now, you ready for this? The probability with 15 is our mean, standard deviation of 6. The probability of selling 20 or less would be from there to the left. If we sell 20 or less during the lead time, we're not running out. But the probability of selling 20 or more is to the right. So if we're right here, right below one standard deviation, right in here somewhere, you can almost estimate that percent chance of running out based on the empirical rule. You know it's going to be less than 50%. Matter of fact, it's so close to one standard deviation, it's probably only like 15% or somewhere in there. Let's take a look and see what matter of fact, here, wait, let's do this. What's the probability we're going to run out with a reorder point of 20? Okay, 20 minus the mean of 15, divided by the standard deviation of 6. 20 minus, that's 5, over 6. This gives us Z. Z is 5 divided by 6. 5 divided by 6. That all it was?
83.
0.83.
0.8333.
Okay, 0.83, because we only use 2 digits on the Z chart. But 0.83, which is right there, would be our probability of selling 20 or less, which means we wouldn't run out. The question is, what's the probability we will run out, which means we'll sell 20 or more? This is how it's used in business. What we're about to calculate is the probability that if we have a reorder point of 20, when really we usually only sell 15, it should be a very low probability of running out, and that's what this manager wants because there's too much competition. Let's see what the probability is. 20 minus 15 divided by 6 is 0.3. We look up 0.83, 0.8 in the left column. We go to the 0.03, 0.7967. Whoop, whoop. 0.7967. Subtract it from 1 because we're trying to find the probability that we'll sell 20 or more. So this equals 0.2. What's the opposite of that?
2033.
There it is, 0.2033. All right, so I want you to think about this now. You're the manager of PepZone. AutoZone's right down the road. You're going through. You're working with you're the manager of the whole thing, but you're working with your inventory manager who said, let's meet. We're working out new reorder points. The question the inventory manager is saying to you, you're the general manager of the whole thing, is 20 fine? Should we leave our reorder point at 20, or should we move it? Move it. Who said it? Okay, move it. Which way you want to move it? You want to go 20, less than 20, more than 20? What? And why do you want to move it? Because this is a hypothetical question, and either answer is correct, actually.
The probability for me is too high.
Too high. Because you have a competitor right down the road, you don't want to take a 20% chance of running out, right? You're saying that's too high. So if you move it up to 21, that would lower the percent chance of running out then, if reordering having one more in stock, correct?
Yeah.
Yeah, that's pretty good logic. Some people say, well, you know, I usually take a 50% chance of running out, and I have a reorder point of 15, so I'm going to leave it at 20 because it lowers me to, you know, I have an 80% chance that I'm not going to run out and I'm not going to lose a customer, and I'm maybe willing to take that 20%. But I want to tell you something. When a company, especially a retailer has one right down the road, they will most likely calculate a reorder point that is too high, but they're that scared of losing the business to the competitor. So they might do what he's saying and say, I want to work this backwards. I want to take this 20% and turn it into like 10% and work the whole thing backwards and figure out what would that be. I'm making that a variable. I'd look up 10% on the chart, which would be 90%, because 1 minus 90. I'd find out what that Z is, and I'd take that Z and I'd say, okay, what does this have to be for that Z to be equal? And then I use algebra and figure out that X, and that would be your reorder point. Which, if you're only going to 10%, that's probably going to be something like, who knows, 23 or something. Now, here's what's happening. Yes, this company's going to have more money stacked up in inventory, but they say they feel I'd rather have money held up in inventory than to lose business to the competitor because we ran out. And that's the situation, when a highly competitive situation, that's the way you go. These are the calculations to manage the inventory as to what your reorder point is. All right, let's go. We got to go to uniform. Uniform starts on slide 4. Chapter 6 PowerPoint, slide 4. This is uniform. You ready for this? This is uniform. Uniform, uniform, uniform. I want to give you another word that means uniform. Evenly distributed. Evenly distributed. Uniformly distributed, evenly distributed mean the same thing. A perfect example is a roll of a die. If that die is manufactured, you know, for Vegas, where it weighs exactly the same on every side, no matter how it's tilting, every number on that die has the exact same equal chance of coming up when you roll it. A 1, a 2, a 3, 4, 5, or 6 have equal chances. That's called a uniform distribution. No matter how times we roll it, every number, like if we rolled it 1,000 times, each number would be darn close to coming up, you know, 1/6 of the time. Because there's 6 numbers, they're evenly distributed. That's called a uniform distribution. The number one calculation for a uniform distribution is to get that density function. Density function. The density function is 1 over parentheses, the range of the uniform distribution's largest number minus the smallest number. I want to make sure everybody heard me. The uniform distribution starts with the density function, and you're being told that the uniform distribution is between a 1 and a 6, right? The roll of the die. So the density function would be 1 over 6 minus 1. The largest number minus the smallest number. This equals 1/5. That would be your density function for the die. This die is uniformly distributed between 1 and 6. Every number has an equal chance of coming up. So there's the density function. The density function is then multiplied by whatever you're being asked to find the probability of, which will make sense in a minute. Let me show you this example. Remind me, we gotta come back to expected value and variance. All right, ready? This is salad. This is the buffet. We talked about this, I think, in a previous lecture, but here we are again. We're at the buffet. It's a salad buffet. People go fill their plates up. They come up to the cashier. They put it on the scale. It says, sampling suggests that the amount of salad taken from customers is uniformly distributed between 5 and 15 ounces. All right, let's get the density function. Help me out. 1 over what?
15 minus 5.
15 minus 5. There it is. 1 over 10 is your density function. Now, whatever question's being asked about has to be multiplied by 1 over 10. And that's how you get your probability. Let me start with, what's the probability of the next salad being 6 ounces or less? Well, what's the lowest it could go?
1.
Can't go to 0.
1.
No, can't go to 1. 5. So, you ready? You take the density function times the range of whatever the question is. I said 6 or less. 6 ounces or less would be 6 minus 5. 1 times 1/10, 10% chance that the next salad would be 6 ounces or less. Let's do another one. The salads are uniformly distributed between 5 and 15 ounces. What's the probability the next salad is between 6 and 10 ounces? Both numbers are in that range, right? So we use the density function again. 1/10 times, what did I say, between what and what? 6 and 10? 10 minus 6, the larger number minus the smallest. So that'd be 1/10 times 4. That'd be 4 over 10, 0.4. 40% chance the next salad will be between 6 and 10 ounces if it's uniformly distributed between 5 and 15. Does everybody get it? You got to get that density function, then whatever the question is asked about. I want to do one more. What's the density function? 1/10, so we know. Here we go. Times, what's the probability the next salad is going to be 12 ounces or more? 12 ounces or more. Help me out. What's this numbers here? 15 minus 12, which equals 3. 1/10 times 3 equals 0.3. There is a 30% chance that the next salad will be between, I think I said 12 and 15 ounces. Oh, I said 12 ounces or more. We know the highest you can go is 15. That's why we use 15 with the 12. So I said 12 ounces or more, but the highest you can go is 15. So that's why I use 15 minus 12. The most common mistake on a quiz, because these are so easy, is forgetting that you can't go lower than the lower number and you can't go higher than the high number. So if I said 6 or less, accidentally using 6 down to 0 for the parentheses would be wrong because you can't go below 5. That's the most common error that takes place. But the density function everybody seems to get. It's 1 over the range of the whole uniform distribution. Yes, go.
Where'd you get 1 over 10?
Where did I get what?
1 over 10?
1 over 10? 15 minus 5, 1 over whatever the largest minus the smallest of the whole range of the uniform distribution. Let's look at your homework and then we're doing it in class. The first 3 problems are uniform distributions. Help me, just tell me what the density function is for this first problem. That's all it is density function, all right? Now let's go to the second problem. If the customer's salad are between 2.5 ounces and 8.5 ounces uniformly distributed, use the correct formula to manually calculate, showing you detailed work, the probability that the next salad is 6.4 ounces or less. What's the density function? 1 over what?
8.5.
8.5 minus 2.5. There's the density function. Very good. That's all I want to make sure you get, because that's the most important part. Then you multiply that times whatever the range is the question is. Get it? The first problem is only asking you to give the density function at all. The second problem we just talked about, and the third problem says, if a random variable x is known to be evenly distributed, see those words? They mean the same thing as uniform, same thing. Evenly distributed between 24 and 66, manually calculate the probability of x having a value between 55 and 60. Same thing, gotta get that density function and multiply it the range of the question. Everybody feel they can do the homework? It's almost too easy. If you attack that homework after class, you'll have it done in less than a half hour.
So the expected value and variance aren't.
Oh, I'm sorry. Thank you for reminding me. They're not on the homework, but here they are. The expected value is you add the largest and smallest number of the uniform distribution, divide by 2. That's it. That's your expected value. So on this one, 8.5 to 2.5, add these two numbers, divide by 2. 8.5 plus 2.5, whatever that equals, divide by 2. There's the expected value.
5.5.
Thank you. The variance is you subtract the two numbers, the largest one minus the smallest one, square it, then divide by 12. You take the largest minus the smallest one, now we'll do this one again. 8.5 minus 2.5 equals, what is that, 6? 6, square it is 36. 36 divided by 12 equals, how lucky is that? That's a 3, isn't it? That was just luck that it came out 3. It should have been point something, something, something usually. It's always divided by 12. That's just it's in stone, no matter what. Okay, you ready for the in class?